Section 8.2, Problem 2 for our notes, factoring again. Similar type problems, but we're going to find something a little bit different when we end up working these out. So here I see a 3 and a 12. I'm going to pull out a 3, and then I'm left with an x squared minus 4 on the inside. But as you recall, so 3 times x squared is 3x squared, 3 times negative 4 is negative 12. But as you recall, this right here, x squared minus 4, is actually the difference of squares. Remember doing that? So that's kind of where we had, well, I can square root that and square root that. So that really gives me an x and a 2, an x and a 2, where I can go plus 2 and minus 2. And I have a 3 at the front. Remember the difference of squares? I'm having trouble remembering that. Anytime I see one of the numbers of our counting or our perfect squares, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. Anytime I see any of those numbers, remember that's a perfect square, so in this case I have a difference of squares. So if we can break this down, then we're going to break it down. And that's kind of what all 6 of these problems are going to do. That's kind of the purpose for why we're factoring. So when I look right here, I see a 2, a 12, and a 16. 2 looks to be the biggest number that I can pull out of there. What does that leave me with? It's like I have an x squared, a minus 6x, and a plus 8. 2 times negative 6 is negative 12. 2 times 8 is 16. And here I've got a trinomial in the parentheses here. So this is where we're going to play the game of what multiplies to 8 and adds to be negative 6. Well, it looks like 2 and 4 add to 6. If they're both negative, then I have a positive 8. So in this case, I've got x minus 2, x minus 4 with my 2 in the front. And lo and behold, that is my answer. Okay, let's try problem C. 2 and 18, pull out a 2. Pull out an x. Inside I'm left with just an x squared minus a 9. So 2 times 9 is, or 2 times negative 9 is negative 18. I already have the x there pulled out. 2x times x squared, x, 1 there, 2 there, gives me 3 there. And we have, I noticed this 9 here is one of these 9s up here in my list. There's no middle term, so this is a difference of squares. So I'm going to put this down as x plus 3 and x minus 3, because the square root of 9 is 3. So the difference of these squares gets us that result. Bring the 2x down. That is our answer. Getting the hang of that? Now we're going to move down to some more problems here. These are a little bit trickier, but not too bad. I see a 75 and a 27. What number goes into 75 and 27? Might not be obvious to you, but if you play around with it a little bit, they're odd. One of the good odd numbers to try possibly is a 3, and sure enough, 3 does go into that. I see that there is an A, and I see, but there's no A over here. Can't pull an A out. I see a Y here and a Y here. So pull out a Y. 3 times what is 75? 25. I didn't pull any of the A's out. I did pull the Y out. 3 times what is negative 27? Negative 9. Can't pull a P out because there's no P in this term. I did pull the Y out already. So, in this case, that's what I'm left with. So let's double check. There's a lot of letters going on here. 3 times 25, 75. Y is pulled out. A to the 4th goes from there. 3 times negative 9 is negative 27. The Y is there, so it shouldn't be inside. The P squared, very good. 3y times 9p squared is going to give me 27p squared y. Now, and unfortunately I had rolled this thing down. If you look back at the top of the paper that I had just done, 25 is one of our squares. and 9 is one of our perfect squares. So what does that give us? That's going to give me a 5 and a 5. This here is going to give me a 3 and a 3. And if you recall, this is similar to one of our more difficult ones. I'm going to cut this pile in half. So that's a squared, and then I'm going to cut that pile in half, so I'm left with a p and a p. So a plus and a minus. So 5a squared plus 3p, 5a squared minus 3p, and this is left with 3y. If you need to, go back and look at that section where we were talking about the difference of squares, because that's the difference of squares. It gets us the red part, there's 3y is the new part that we're looking at the factoring. Part E, this gets back a little bit easier, so we like that. I see a 4 and a 4, so let's pull out a 4. But also I can pull out an a. So now I have a 4a squared. Now the only difference that we're going to look at doing here, because there's a negative with this 4, that this really is a negative 4, it's going to be most beneficial to pull that negative out. Okay? So let's pull that negative out and see what happens. Negative 4 times 1, so I'll put an optional 1 in here if I can grab my pen. If I pulled a squared out, then that leaves another a squared inside. Now negative 4 times what is positive 4? Negative times negative is positive. So I'm going to put a minus, put an optional 1 in there. And then I actually have a squared. I pulled all the a's out of there, so in reality this one is not optional because no variables came with it. So I need to have that. So I really have negative 4a squared times a squared minus 1. And that one, notice this 1 is a perfect square, and I notice an a squared there, so we're going to make this be a plus 1, a minus 1. And in the front, I've got my minus 4a squared. That is my final answer. So again, if we have a chance to pull out a negative from the very first term, let's pull that negative out. In this case, I pulled the negative 4 out, and that made this then, I needed a negative 1 here. Because I pulled both the a's out, then I didn't have any variables left, so I needed to have both those. Again, 1 is a perfect square, just like 9 and 25 are perfect squares. Let's go over here to F. I see a negative 4 at the front, a 20 and a negative 24. So let's pull that negative 4 out. I think you guys were already on that. I'm going to pull an a out because that's an a in every pile. And what does that leave me? Leaves me with an a squared here. It leaves me with a minus 5a and a plus 6. So that is, I'm going to use some whiteout tape here since I don't have an eraser. Let's go back, let's make sure that that is, looks like the minus that it is. So now I have negative 4a times a squared is negative 4a to the third. Negative 4 times negative 5 is positive 20. a times a is a squared. Negative 4 times positive 6 is negative 24 with the a. Again, here I have a trinomial, so we're going to say what multiplies to be 6 and adds to be negative 5. And in this case, that's going to be minus 3 minus 2. Negative 3 times negative 2 is positive 6. Negative 3 plus negative 2 is negative 5. I'll put my negative 4a in the front. And it's just that easy. Maybe not, but that's how we do it.